Hey everybody, here's tutorial 2, part 2. We're going to continue working with this environment. So first of all, some of our descriptions in the comments are no longer accurate. You're going to want to update that anytime you're working so that your comments match what's actually going on. And you'll notice one conspicuous omission here from our lighting scenario. These objects don't cast shadows. So that is actually an attribute of lights. We can say shadows $1, and that will turn on and off shadows. I'm going to add another attribute here because computing shadows can be very costly for the computer. So we are going to use shadow quality low, and in this case low is spelled L-O. So shadows $1, shadow quality low. And because shadows is a Boolean attribute, it's either 1 or 0, we can use our trick of connecting a toggle to a message box where it's shadows space $1, and that will allow us to turn on and off shadows for the 3 lights. So now we can see shadows are on, and we get a much more realistic rendering of the scene because our lights are casting shadows. And if we drop our green cube, we can say position 0, 5, 0, mean we're going to make this cube jump to 5 meters above the center point of our world. It falls, and we can see its shadow is rendered as well. And then this gives us a handy button to cause our cube to jump down anytime we want. And we can combine this with a scale message to make the cube smaller. So you can see that with the addition of the shadows, our scene becomes quite dark, and it's a bit hard to see things. It's nice, it's very dramatic, and you might want this for a project, but for a tutorial, it's a bit dim. So let's add an additional light, jit.gl.light, and these lights should be placed into the world, T2, and we should go back and put T2s into these as well. Just in case we have multiple worlds open, we don't want the software to be confused as to which world the light belongs in. I'm going to position this light directly overhead, maybe 6 meters over the center, and I'm going to use a different light type. I'm going to use type point, and a point light is like a light bulb or the sun. So my jit.gl.light in world T2 at position 6 meters above the center of the world, type point, and then to specify the color of a light we use diffuse, and we'll make it quite a dim light, say 0.125. Just a little bit of extra lighting to make the scene a bit brighter. And notice that I'm not going to turn on shadows for this light. Why? Because this is a direct top light, so the shadows are going to be mostly right underneath the objects. And remember that computing shadows is computationally expensive, so we don't want to compute any shadows we don't absolutely need to. Now, obviously what's happening here is our screen is getting really unmanageably cluttered, so it's time to go and do some encapsulation. I'm going to select my sculpture here, say Edit, Encapsulate, and call it Sculpture, and we can see that the objects are reinstantiated when we encapsulate them, so I need to send the textures back to the objects, and any messages that you use to configure your objects will need to be sent again. We can see in the subpatch that the inlet is simply sending the textures into the jit.gl.material. Nice thing about subpatchers is we can rearrange things for readability, and you need to do that in your tutorials and in your own work. Rearrange for readability, particularly now in the beginning stages while you're just learning, to make your patches as legible as possible. Another thing we can encapsulate is the lighting, but when you encapsulate lighting, you have to be very careful because it will not necessarily recompute properly until you open and close your patch, so you might get some unexpected results. So when I rebuild lighting, I'll actually turn off my world, stop it from rendering. So the first thing I want to do here is management before I encapsulate. If I'm going to encapsulate like so, edit, encapsulate, I'm going to have these toggle boxes outside my patcher, and I might forget what they're for. So before I encapsulate, go to Edit, De-encapsulate. I'm going to label these toggles. Call this one Shadows. Call this one Key Light. Call this one Fill Light. Make a note that that's the red light. And call this one Backlight. And I can certainly add and enable to the new light that I just made. Call this Work Light. So I'll take all my lighting stuff, edit, encapsulate it, call my encapsulation lighting, and build my little lighting control panel. I have my shadows, I have my key light, fill light, backlight, and my work light. And Command Y will tidy things up into a nice row. And now I want to save this, close the patch, reopen it. Because otherwise my lighting may not render correctly. And also I do want this work light connected to my main toggle. I can also make my shadows connected to my main toggle. In fact, just to remove all of these extra lines, I'll just make an extra toggle here and connect it to all of my lighting related toggles. That means instead of having 5 patch cords coming down the screen, I have 1 patch cord coming down the screen and then 5, that cube fell over again, that's funny, 5 shorter patch cords related to my lighting. Another thing you are going to find useful, I'll show it to you now, is if you option click and drag over anything, any patch cords or objects that you want to hide, you can say under Object, Hide on Lock, so that when you lock, those disappear. And you can do this with any patch cords that you want to hide. So I can option click and drag over these patch cords and Object Hide on Lock or Command K. And then when you lock your patch, see now I've got a nice lighting control panel here without the clutter of patch cords. Is there anything else I can encapsulate in this moment? Sure, I can encapsulate both of these, in fact. I'm going to leave the floor out for a moment, but I will encapsulate my green cube. Edit, encapsulate, green cube, Command J to fix with, and I've left my message, my control outside, so you can see how much screen landscape I've recovered here. Quite a bit of screen landscape. So the next thing we're going to look at is we're going to look at just one of the properties of physics objects, which is their bounciness, because this gives you a lot of flexibility in terms of how objects interact with each other. So I'm going to first make a copy of my green cube, and I'm going to call it red sphere, and these of course are in all caps, meaning I can change them to whatever I want. And I'm going to go into my red sphere and make it be a red sphere. So change my shape to sphere, change my physics body shape to sphere. I'm going to change the scale to 0.25, make it red, and there's my little red sphere there. And I'm going to add a new attribute. And as always, I'm going to change into Monaco 14 point just for readability. I'm going to add a new attribute, which is restitution. And restitution is essentially bounciness. It's how much energy of an impact is transmitted back into the object in an opposite direction, how much rebound the object has. So I could say a restitution of 0.5, meaning 50% of the energy of the object is going to be transmitted back into the object upon impact. Now you notice that when I did that, it actually didn't bounce at all, because also the objects it's hitting need to have restitution as well. Let me move this over so it's only hitting the floor 1 meter to the left of center, 5 meters above, and 2 meters towards me. And it has restitution, but the floor doesn't. So I need to go up here to my floor and give my floor a certain amount of restitution as well. I'll make my floor like 0.75 restitution. So my sphere has a restitution of 0.5, my floor has a restitution of 0.75, and that's going to be quite bouncy, as you can see. If I want things to be bouncier, I can make either the floor bouncier, for instance, give the floor a restitution of 1, and that's going to make the bounce be higher. If everything has a restitution of 1, the bounce will put all of the energy back in, and it will bounce forever. Although, friction is going to eventually probably make it stop bouncing, but it's an extremely, extremely bouncy surface. So you want to be careful with restitution of 1. A restitution greater than 1 is going to make for accelerating rebounds, which can be interesting, but also can get quite chaotic. So let's turn our restitution back to 0.75. But we notice here that if we drop our ball onto our sculpture, so if we drop it from 5 meters above the center position, it doesn't bounce. Why? Because our sculpture has no restitution. So we'll go into our sculpture, and again, as always, Monaco is going to make things readable. We'll do a restitution of 0.5 on the sculpture. That will make the sculpture itself somewhat bouncy. And I'm always careful about making my ats line up for the sake of readability. As your patches get more and more complex, this will become increasingly important. I drop the sphere onto the sculpture, and we see the sculpture itself is now bouncy. So the next thing I want to look at is making multiples. And there's several ways to make multiples of objects. There's one way that I'm going to show in this tutorial for making multiples of, say, 5 to 100 objects, where you want to be able to have fine individual control of each object. There's another way of making multiples that we'll learn later if you want to make massive quantities, hundreds or thousands of objects, but you sacrifice a certain amount of individual control over the objects. So this first method of creating multiples involves taking the thing that we want to make multiples of. Let's say it's our red sphere here that we just made, and we copy the objects related to what we want to duplicate. Say edit, copy, and then we're going to go over into our project and make a new file in our project. We'll call up a file dialog box. We go into the patchers folder, and we're going to call this sphere underscore poly. And note that this is in all caps, meaning I could have called it anything I wanted to. I called it sphere because it is a sphere, and I called it poly because that is the object that we're going to use to create multiple instances of this sphere. And we can see sphere underscore poly appears in our project, and here's our empty patcher window, and we paste in the thing that we want to create multiples of. And this is very much like an encapsulation, but slightly different. In an encapsulation, if we want inlets and outlets, we use the inlet object or the outlet object. In a poly, which is what we're making now, it's similar, it's the in object. And we can create as many inlets using the in object as we want. It takes an argument for its inlet number. So in this case, we want 3 inlets because we want an inlet that talks to our grid shape, we want an inlet that talks to our material, and we want an inlet that talks to our physics body so that we can send different messages to each of these things. And there's one more thing we need to add that I'm not going to explain fully right now, but it is necessary for using the enable message. You're going to need to create the route enable object. And notice this is in all caps, meaning we could have called this whatever we wanted to. I choose to call it enable, and you should too for now, particularly because I'm not going to fully explain what's happening here. And a message of lowercase enable $1, and we're going to connect this to both the grid shape and the physics body. And then, very importantly, the right outlet of right enable needs to go to the grid shape. So just build this exactly as shown, and I'll explain why we need this addition to our poly later. But the important takeaway here is we're making something that's like an encapsulation, except it uses the in object instead of the inlet object. So save that. And now I'm going to get rid of my P red sphere, and I'm going to add poly tilde, and tilde is the upper leftmost key on the keyboard with the shift key depressed. Poly tilde, and I'm going to put in the name of the poly I just made. So poly tilde space sphere poly, and then how many of them I want. Let's make 20 of them. And it takes a moment to render, and then there's 20 of my bouncy red spheres. If I want 50 of them, it's going to take a moment to render them, and then there's 50. And each of them is obeying the physics rules, and each of them has the restitution that we applied. So if we open up this poly, we'll see that we have something very much like an encapsulated patcher, except we can't edit it. Instead of a lock, it has a pen. And if we click the pen and then click the lock, we're editing the file here in our project that we are then replicating using the poly tilde. So let's take a look at how our inlets work. They work slightly differently. If we want to send a message to all 50 of the objects, we need to preface our message with target 0. Target 0 is a message meaning I'm targeting all objects. So if I want to make them all the spheres white, I would say target 0, comma, color 111, and I'm going to send that message into the first inlet because the first inlet is the one connected to the grid shape itself. And all my spheres turn white. We can see this, they're a little reddish because I have a red light in my scene. If I turn off my red light, I can see that they're actually all white. Turn my red light back on, and some of them will have a red glow. Turn them back to red. In my third inlet, these are my instructions to the physics body. So I can say target 0, position 050. So take all of these spheres and move them to 5 meters above the center, and they'll fall down. They can't, of course, all move to the same place, so they will expand from the center point that I'm defining and fall down from there. And if I want to add a texture to my object, I can do that using the middle inlet, which will send to the jit.gl.material. Now here I have a bit of a problem because I can't use target 0, comma, so I can just use a separate target 0 message. Target 0. And this wants to be to the right of the texture I'm sending in. And this is going to take a moment to render because it's taking this image and turning it into a texture for each of the spheres. But once it does, we'll see that the individual spheres all bear the texture that we've sent to them. And this will actually be easier to see if we change our objects into cubes. So I'll say target 0 shape cube. And now I need to change the shape of both the physics object and the grid shape. So I'm going to send this shape cube message to both. See, they become cubes. And now I can drop them, and it's just easier to see here that the texture has been applied. Now you can see how bouncy and jittery these cubes are. That's because of the restitution. There's quite a lot of restitution on these cubes, so they just don't stop bouncing. So if we can either turn down the restitution, target 0, restitution 0, which will make these cubes no longer bouncy, if I spell it correctly. Restitution 0, and that calms them down. Or I can just change them back into spheres, like so, and then turn the restitution back up. They'll be bouncy. So the one thing I said is that this way of creating multiples makes it easy to address individual shapes, and that's true because target 0 addresses all shapes, but target with a number other than 0 here will address that particular shape. So in this instance, we have 50 shapes. They're numbered 1 through 50. So for instance, if I wanted to target shape number 10 and make it a scale of 1, I simply send that message into the right inlet because that's a message I want to send to the physics body, and there it is. That was shape number 10, and I just gave it a scale of 1. And if I want to change the color just of shape number 10, I can change the color of it. So I've made it yellow. So a couple other messages that are nice to use with our physics objects are impulse. Impulse is how we move physics objects without making them jump to a new location, because we see that we can use the position object to make them move immediately to a location. But if we want to have an object move of its own accord, we can say impulse, and then we give it impulse in the XYZ direction. So for instance, if we want it to move to the right, we can give it an impulse 200. That will give it a rightward impulse. And we can see every time I hit that, my shape pushes to the right. If I want it to have an upward impulse, I'm fighting gravity, so I need to give it a strong upward impulse. And of course I can use impulse with target 0 if I want all of my shapes to have an impulse in a particular direction. So target 0 impulse 050 means all shapes jump straight up. We can see they do. Which is a much different effect than saying target 0 position 050, which just makes all of them jump to that location and then fall. The other thing I want to introduce you to is changing gravity and changing the world box. Gravity is, of course, simulating real-world gravity. When we impulse things up, they fall back down. But we can use the send phys message to send messages to the physics simulation. So send phys gravity 0, 0, 0, and that's going to put us in a physics world. And this is a message we send to the JIT world. Put us in a world with no gravity, so that when I, for instance, give the impulse upward, things don't fall back down. They just stay up there. And when I move them to a new position, they'll bounce off of each other and bounce around, but they won't fall down because we've turned gravity off. If we want to turn gravity back on, this is gravity is expressed in meters per second squared, which on the Earth is 9.8 meters per second squared downwards, or negative 9.8 meters per second squared, and boom, gravity is back on. The other thing we can see here, if I turn off gravity again and I give the upward impulse, everything stops at a certain point. And you probably already noticed things are not falling off the edge of my little platform I made. That's because by default there's a world box, and the world box is a 5-meter cube. So I can say send phys world box $1 and use a toggle to turn my world box on and off. So now I have no world box. If I turn gravity back on, objects that roll off the side will fall off the edge. If I turn my world box back on, those objects will all come back into the world. World box off, gravity off, and send an upward impulse, and my objects will keep going upwards forever. They have no upward bound. If I turn my gravity back on, they will all fall down, and well, none of them fell off the edge in this particular case. But if I, for instance, gave them an impulse to the right, some of them would fall off, and they'd just fall forever. As I zoom out, I'll see that these objects are just going to continue falling infinitely into space. So there's also, you can change the scale of your world box. In addition to turning it on and off, I can say send phys world box underscore scale, and then, for instance, just make my world box bigger, but not infinitely big. So 10 meters on a side, turn my world box back on, and now inside my world I can see that my objects all gather 5 meters below zero. They won't fall infinitely. They're just falling in a larger world box. So they'll go off the edge, but they'll all be stopped by this 10 meter by 10 meter by 10 meter box around my world. Sometimes it gets a bit hard to see things because our background is always gray. That is the erase color. Erase underscore color of our world, which we can set to anything we want. So there's a world with a white background. So the thing about an erase color is it actually has 4 components: red, green, blue, and transparency. and it's easier to see the movement of these objects when our erase color is 1111 or white. If we want a light gray erase color, we could do 0.8, 0.8, 0.8, and that fourth argument, just leave it 1 for the moment. So 0.8, 0.8, 0.8, 1, or 1 point. And that's giving us a light gray background. And the final thing I'm going to show, because you can start to see the importance of it, is see how these edges in my graphics window are a little bit pixelated. They're a little bit ratty. We can turn on a feature of our JIT.world, and it's best to do this with an attribute, because once it's on, you just want to leave it on. It's FSAA space 1. Turn my window back on. It's going to take a moment for it to render. But FSAA is going to improve the rendering quality so that when, for instance, I set my erase color to a light color, I'm going to have smoother edges on my objects.